Good morning, teachers. This is Heuristics for Teachers, Fall 2020. A course I started in September and we'll be drawing to a close just to wrap it up. But it's not the kind of thing that ends and that there's so many little trailheads you could follow. For example, for those just joining us, we have been scrolling through the history of the Columbia Gorge, focusing in particular, most recently, on the character of Sam Hill and his Mary Hill Museum and so forth. And I've been sharing my research with the Quakers, so here you'll see a site called quaker.org, and it's just another example of integrating American Transcendentalist threads in a curriculum. Now, you may not be making curriculum bundles quite the same way. You might be operating in a different river basin, a watershed, a bioregion. You have different memes. The idea is, how do you weave together these memes? Like I would say, synergetics goes into physics for strong examples and then beads them on its own necklace that's not physics, right? And I'm getting synergetics integrated into kind of the American Transcendentalist tableau, which I'm kind of reviving just for the purpose of giving it somewhere to park, right, in philosophy. And then we'll talk to the pragmatists over the fence, right? We'll have friendly neighbors in this new development in philosophy. Now, the math innovation and where, okay, I'm going to do some spot welding here to help you like integrate for further research, right, for all of us. Possibilities. I've got connections I want to make. So with the Martian math, which is a lot where this all got started, you've got your heuristics for teachers in the digital mathematics context. This is being offered as a Silicon Forest offering. So it's coming from a specific subculture. There's kind of values here. You can think of Seattle, Portland. Portland's been in the news lately for more than one reason. Important city. And so there's a lot about Sam Hill, or a lot about Portland, I meant to say, in the Sam Hill Columbia Gorge story. Again, we're doing place-based. I want to leave you with an image here, a mnemonic, a memorable image. Mnemonics. That bridge right there in the background. The train with Queen Mary from Romania, it parks on this bridge at some point so they can have lunch and for a last time gaze out upon the gorgeous beauty of the Columbia Gorge. Right? They're going home, basically. I mean, she knows she'll never be back here, right? She's saying goodbye to Sam Hill, although they managed to cross paths in Chicago in some distant way, I think a little later maybe. I forget. So there's a lot more research here. But you'll know that the Columbia Gorge then morphs into a hydroelectric power situation, a big one. This is the dam at the Dalles, which is not that far from Stonehenge and Maryhill. Then there's the Bonneville Dam, which is further towards the Pacific, beyond this one to the west. Going behind us is the rest of the Columbia Gorge. And remember this lower Salween River in the last video? Remember, we're interested in world game, and I'm just showing an example of how it's being played, how terraformation has been occurring in the Columbia Gorge context, right? So I'm encouraging you as teachers to not just say, oh, you're telling me I need to teach about the Columbia River. And I'm saying, no, actually, you might want to, but I'm saying what river is close to you? Where are you on the geospatial database? And work out from there. Like work concentrically outward, build your story outward to the world from where you're at, because you're showing others how to grow into where they're at, if you understand. It's a good way to teach because you're coming from experience and you're right there yourself in a lot of ways. I'm saying autobiography is a good thing, yes. So the math trick, you could just say we have this one trick pony. You could, let's be critical of this whole thing. We're just got a harp with one string, and that one string is no, Fuller shouldn't be famous for the geodesic sphere. I mean, yeah, he was totally focused on that later. But really, what was focusing his mind and how he got to the sphere was thinking about a multiplication in a different way, you could say. Now, I'm retelling the story. This is not exactly how he told the story. But check out this image. Now, we met this guy before this course started, Heuristics for Teachers. We circled around a website in Canberra, Australia, by a gentleman who figured out for himself he's like a watercolor painter. This is not deep math. The mathematician would say, oh, I could figure this out in an afternoon, perhaps. But what he discovered for himself was that if you multiply two numbers by each other, that the area expressed in terms of little triangles. So you see how we've got this big equilateral triangle, equiangular triangle, all divided up into a high frequency, like similar things of itself, right? It's been tiled with itself at a smaller scale, and it's got this frequency or whatever, but we're multiplying 4 times 3 here. If you count up the units, 1, 2, 3, 1, 2, 3, 4, you get this green rectangle. Now, that doesn't look easy to compute the area of. And so already it's like, well, what's good about this? I don't really know how to compute this area. Well, I could figure it out. So you figure it out, you do a lot of computations, and okay, so it comes out that it has the same area as 12 of these smaller triangles, the ones that express the units to begin with. Just like, kind of like squares would do, but different. And it's like, okay, all right, we'll take that as a given. Like, do what you need to do to prove it, check it out. Okay, you get that it works. You think it's like water, actually. Like this green stuff is like a fluid, and how you're putting it in the triangle is kind of cool. And anyway, it's different. So this is where we link to Wittgenstein and language games. Now, that's an important Vienna Circle philosopher who did a lot of his work in England. And he actually overlaps with Donald Coxeter, who was one of his students, didn't really like philosophy that much, but still liked Wittgenstein enough to lend his suites as a place for them to meet. Small group, Wittgenstein and his fans. It's very, English education system. We should listen to Aldous Huxley or listen to Alan Watts describe what Aldous Huxley went through to get to be Aldous Huxley. That's on YouTube somewhere. So we do a lot with that trick, the fact that we can multiply two sides of a triangle and get the area in terms of unit triangles is like a language game, as I was saying, in the Wittgenstein tradition. And he loved to do little language games around mathematics in particular, investigating how does this word dimension arise? How do we use it? What does it mean? Let's follow the terrain. It's not something where you introspect to figure it out, really. You have to really do some anthropology to see how people use the word dimension. And in jumping into and using Wittgenstein's focus on investigations with Buckminster Fuller's innovation here, a little different language game. Now, like I said, this guy in Canberra, he discovered it independently, and I don't think he knew about Bucky, or if he did, he doesn't talk about him at his website. So I'm not saying, oh my God, this is what makes Bucky a genius all by itself. But then, before we get into who's a genius, let's check it with a tetrahedron. Would it be true that with a similar approach to a tetrahedron, dividing it up with sort of parallel planes to each face and so on, and notice there's a lot of perpendicularity in a regular tetrahedron. So we're not off really on the wrong foot with XYZ. It's just opposite edges, always one to opposite the other. They're always perpendicular to each other. Isn't that interesting? But that's not the focus right now. The focus is if I do A times B times C, bring in another edge, does my volume equal those three numbers multiplied, basically? And those refer how many you get. Okay, so I do 2 times 2 times 5. This is 20. 20 what? 20 cubes? No, 20 of these little tetrahedrons at each corner. And these oscillate or alternate with octahedrons that each have 4 times the volume. The space filling going on here, called the octet truss or IVM, is similar to the XYZ. It's a ghostly space filler in the sense that you don't need to think it's really there to imagine that it's there. For like XYZ, when we do CAD, so think of Escher's flatworms. This is sort of a different ghostly coordinate system in the sense of space filling tessellation, whatever you want to call it, all space filling tiling. Instead of all cubes, we intermix tetrahedrons, octahedrons in a ratio 2 to 1. And then we find out we can play the same math game of what amounts to, in the end, third powering. In other words, when we scale up as a third power, of course, the tetrahedron illustrates that. And in a simple, straightforward way, and in a way we can then apply to what we call the concentric hierarchy, which, once you add up all this content and park it in philosophy safely, so they don't steal your car, they don't go driving around in like junk physics neighborhood, right? It's like, who gave you the keys, right? That kind of, it's like, I do want to protect synergetics from being driven off the road, right? So I'm not saying other people can't drive it, but figuratively, right? Like, I've got my set of keys, and Martian math adheres very closely to what I'd call the Platonic core. It's like what we want kids to learn, and it focuses around, this concentric hierarchy of polyhedra. Now, the last link I'm going to make is to Ouspensky, and you're going to go, why? And I've connected these two books quite a lot already in previous YouTubes. The idea here is, with the positive futurism of American philosophy, why is it that we're wasting an opportunity? And what keeps us from realizing the American dream of a working planet? And the answer is robotic behavior. We're bots. Can't help it. As humans, we're bots. And the way we become less bot-like is we become more reprogrammable, which in a way is we're just better bots, because we can still be reprogrammed. We're not just frozen in some Cold War posture that we learned from our parents, and now we're being real politic, right? We think we've got a reality principle guiding us. And there's a question here from like American philosophy. It's like, oh, really, right? Are you paying any attention? So, yeah, so there's the spot welds for you. Use the Wittgenstein language game idea to put sort of a circle or sphere around the whole concentric hierarchy language game and say, here's a good example. And look at the ripple effects. Look at how it might have a different meaning of dimension coming out of it and so on. In other words, explore the foundations of mathematics by seeing what difference it makes to throw this little bowling ball into the lake, right? And see the ripples. That's going to be instructive. It's not going to break the lake, right? We're not worried about math breaking, really. But we don't mind throwing in a bowling ball and see what happens. And so think of Quakers like myself as experimenting along those lines in higher education. That's our glass bead game in part, right? I'm not saying everybody. I'm not saying this is a hostile takeover or something. It's just Martian math looks interesting, looks like a good path to explore. Don't have to justify it as some kind of theory of everything. And we do use sort of the spherical mindedness that's encouraged by synergetics to tackle other subjects, and in specific, science fiction. Because against the mirror of science fiction, we can project our steering function, our ability to realize what we're afraid of or what we're drawn towards, and sort of having anticipatorily designed it, sort of move in that direction, right? So science fiction is very consistent with anticipatory design science. So my channel, again, is easy to find on YouTube, and at the point we are now, I have just finished doing Sam Hill's Quaker Legacy. So if you're new to this channel and you're wondering what on earth is going on, if you scroll back a bit, I explain how my blog called worldgame.blogspot.com is a good orientator. In other words, it's got down the right margin a bunch of resources, and I'm encouraging yourselves as teachers, as you develop your asynchronous and synchronous capabilities, that you have certain home pages, basically, that index other home pages. I'm not saying there has to be one grand entrance, but do have entry points for people who want to get oriented. They're interested. Now remember, when Fuller came out with 4D time lock, he wanted Fourth Wayman Ouspensky to get a copy, and he was sure that, he did the equivalent of FedEx a copy of his 4D time lock to P.D. Ouspensky. So there's a connection there. Again, we're talking about a kind of a Russian philosophy. In other words, the Russians are going to help us, and we're going to help the Russians in this meme break the addiction to all this bullshit junkyard stuff that we do and are proud of. Okay, let's talk to you in the near future. Once again, enjoy teaching this material. Watch the slideshow about concept of dimension in synergetics. That will help if you really want to do the synergetics part. All right, good night, good morning, whatever time zone you're in.